the tests that I've seen, there's mixed, it's a kind of a mixed bag in terms of scores. Some of you have done really well. Some of you I hope have done better. It's just a question of, I think, fundamental understanding. And I think that this is a really pivotal point for some of you as far as if you need to understand the material, if you're going to pass the class. And I'll comment on that as we go through it. So let's first look at, so the first question were the free body diagrams. And so I gave you the two diagrams. I told you, and this is pretty typical compared to if you looked at my old tests, especially the one from the last 2 quarters. I had the part 1 where you look at free body diagrams, and all I wanted was you just to draw it. So you notice that those were most likely not feet. It'd be a very large drum that weighed 50 pounds. It was 32 feet long. So most likely they're in inches, but that wasn't important. So the important thing is to recognize that the A bearing was a slider bearing, so it had no reaction in the y-axis, and the B bearing was a thrust bearing, so it had a reaction in the y-axis. The other thing is, when you draw these, I don't expect them to be works of art, but they have to be better than if you just sketched them out in 10 seconds. So, and that's something you're just going to have to practice at it. If your drawing isn't where it needs to be, then it's just practice. If you have to, I mean, I don't have the best handwriting in the world, so it takes me a little extra time, but it's really important that you make these free body diagrams legible. So, for example, this. So here's the first one up here. And so you have, again, AX, AZ, but no AY because this is a slider bearing. Down at the other end, you have BY, BX, BZ. So you just have the 3. You have the load P, you have the 120 pounds on the cable, and then of course you have the weight. So you have to include that because you are given that this drum has a mass. Otherwise, that's all you need. But you don't have to have a perfect cylinder. If you drew it straight as just a line, that works also. But it has to be legible and somewhat neat. And you're gonna, especially if you're an ME, you're gonna have teachers that are a lot more strict about how neat you are. And so it's good to get in that habit now. I know in CE you'll see that too. I can't speak for other departments as much, but so that's this one. And the other one, 1B, what I was looking for is you had ball and sockets. So O and B both had ball and sockets, so they had reactions in the X, Y, and Z. And get that little arrowhead there. And I'll post these solutions once I've gone through and made sure that I have all the drawings off I like. You have the 400 newtons here, and then you have your tension CD. You didn't need to break this up over here because these are 2 internal parts to it. Remember, when you're dealing with a free body diagram, unless you're going to take the thing apart like we'll do in chapter 6, it's not necessary to put reactions. So here you'd have 6 reactions, right? You have CB and OC would have equal and opposites in all directions, and then when you put them together, they cancel. But you don't need to do that for a free body diagram unless you're taking it apart and showing that. Any questions? All right. Okay, so let's go ahead and now this first problem I gave you was a gimme problem. And what I mean by that is it was supposed to be just a really simple problem, something that I've told you how to do. And if you didn't get it, I'm not trying to scold you, but I'm just concerned because this problem was really simple in terms of what the material we've been doing. And if it's still not clicking, this is a time to really look and see what isn't making sense. Because I know I'm not saying this stuff is easy, but this problem was simple. There's a difference. Simple meaning it had very few steps. Doesn't make it easy if you don't understand the basic concepts. So in this one, I've asked you to find a moment about the line B to O. So you have to identify that line, which is -2 in the X and +3 in the Z and 0 in the Y. And then you turn that into a unit vector. So this is all stuff right out of chapter 2. And then you want it to go from the point, any point on the line, to the force. So I picked B to C. So it's C relative to B, and that's a +4 in the Y. I'm still seeing -4. I'm still seeing people go from the force to the line. So you got to burn that into your head. That's not how it works. And I went over this in the review session. So just, if you need to mark it, write it down. For always go to the force for chapter 3, and just write it in bold letters and put it on your refrigerator, whatever it takes. And then the force P, you just break it into its respective components. So it's a negative in the X direction, positive in the Y, just like the unit vector was. And then you have these respective values. So some of you, because of your negative sign error, ended up adding, and so what you get is, this is the basic problem. You'd get this, which was good. That's what I was looking for. And then you'd have your unit vector, get that, but you'd have a negative in it. So then when you came down here, it'd screw everything up, and you'd end up, since a lot of this drops out, this is really all you get. You have -2√13 times 4 times 317 plus 3 over √13 times 0 minus 4 times -679.7. So down here, you ended up with -73.3 minus 2262. So some of you got the answer, which was about -2900. So if you did that, it's a minus sign. It's not the end of the world, but it's what that minus sign represents. It represents the fact that this was not correct. And that's a fundamental thing you want to get under your understanding of. You need to understand that, all right? Because it's going to come back in the final, and you want to be able to do well in the final, especially if your score on this wasn't as good as you wanted it to be. So, but again, maybe with the curve, it'll be high score. I don't know. So far, the test isn't quite as, the scores aren't as good as I'd hoped, given the questions I asked. But that's a lesson for me too. Any questions on this problem?
I just had a quick question about
Yeah.
scoring. So I'm looking through my work and I realized that at some point in my calculations, I accidentally swapped the well, I rounded it to 316, but 317 newtons. I put that in the J component instead of K, which obviously is wrong. I just miswrote it or something like that, and then that screwed up my entire result. But I did
Right.
everything else correctly.
So that's like the way I grade is out of multiples of 3. So I don't know offhand. That could be either a 9 or a 12 out of 15, depending on how I graded it.
All
So
right.
I usually do multiples of, because it's, if I take 1 point or 2 points off, it gets way too complicated for this many. So what I usually do is I divide the scores by 5. So for example, if you out of 35, each level will be 7. And for the 45 point problem, it'll be 9. So, and then sometimes 9's too coarse, so I might break it in half. So there is actually a method to the madness. What I would encourage is I will post the scores when I'm done. And if you guys have questions, if anyone has, if you have questions you want to talk about the test, then come to office hours. We can do it one-on-one, like I said yesterday. So office hours after the test back, if you come to them and it's not that they're not happening, it just might mean I'm talking one-on-one with someone. So,
All right.
okay, and that's for everybody. But yeah, but that's a good question. Yeah, it's I try to look, really what I'm looking for when I grade is not that you got everything perfectly correct, but that the fundamentals are there. And so I understand, it is possible to do that, especially if you look at the XYZ. It's, because we do have different problems, have different coordinate systems. They're not always exactly the same. The Z on top is what I find in a lot of the alternate textbooks I use, but for whatever reason, the textbook for this class, they always like to put Y on as the up axis. Who knows? Okay. Any other questions on this? All right. So let's look at, so the next problem, that was, as I mentioned in the review a week ago, I said you will have some type of 3D equilibrium. So I wanted you guys to all understand that you'd have some type of 3D equilibrium. So you have this 70-pound slab of steel, and it's connected to this massless tube. And so the edge of the steel is right on the ZY plane. And I gave you the unit vector for EA just to give you extra to help with time. 110 pounds, just to make sure everyone knew that was in the negative K, because hopefully you'd see that because it's the same line, but it's not maybe always clear. And then I told you what B and C were. And so as I mentioned in the first problem, I said a slider bearing at B, which means that B has no Y reaction, but C does because it's a thrust bearing. But the key with this problem is I said you don't have to solve for C, but that doesn't mean it doesn't exist. So I just didn't make you solve the direction to C because of time. But what I saw on a few, which is what I didn't want to see, was that it was ignored, and you can't ignore it. And what I mean by that is, if you look at this problem, if you sum the moments about the y-axis, you can solve for the tension AE really easily, can't you? Because you know the only force you have is 110. The 70 has no bearing. And all you have to do is take the Z component of this. So basically, tension AE times 0.575 equals 110. And so if you divide that, voila, you get the answer. So once you had that, though, you couldn't just take you couldn't just then sum the forces in the Z-axis and say BZ plus the Z component of TAE minus 110 gave you the answer, because you're not accounting for the fact that C has a reaction in the Z direction also. So what I wanted to see was, like we had done in the other examples, was that you would set up your matrix. So here's your free body. So you have your two forces here, you have your three forces here, you have tension EA, you have the 110 and that. So your governing equation, this I look for right away. So we know that R B relative to C crosses with B plus G relative to C, where G is just the center of gravity, or however you want to label it, plus D relative to C, which is this point, and then E relative to C, which is that point. And instead of E, I should probably put tension EA, but it doesn't matter as long as it's represented. And all that we know equals 0. So we go ahead and we figure these out because we have all the dimensions up here. Figure that out. We know that what this is. All right. So now that we have everything, we just have to set it up in our matrix, right? So when we set it up in our matrix, what do we get? We get something that looks like this. So we have our 0, negative 6.10 to our reactions. We have our respective distances to 70 pounds. We have our respective distances to our negative 110. And then we have our respective distances, and then there's our components of EA. So a lot of this drops out because of the zeros. So I just put them directly into IJK equations. So if I did that, I found with the J, I could solve for EA directly. Then I could just plug that in here and solve for my subsequent DZ and DX. Now I could have asked for C also, and you would have just had to have gone back and summed all the forces, but I knew you could do that, so it wasn't necessary. So your final answer, negative 63.1, and dx 174.0. Thereabouts. If you round it and it's a little off, that's fine. So this was exactly like the homework, exactly like the example. I don't think there's any trickiness here. So I guess the question I have is, what part, because not everyone so far has got this. And I'm just curious, like, what was the disconnect? Because this helps me too when I write these tests. Was it too much, too little time? Was it not clear what you were asking for? What was it? Any comments?
For me
For me,
personally, oh, you can go first.
oops. Okay, well, for me, the confusion came from like not knowing where the point of application of the tension was. I didn't know if it was at point A or at the corner of the plate. So I think I got my R vector wrong.
So, so, so you didn't know that it was emanating from here to here. Was that it?
Yeah, well, because sometimes like in the homework, I feel like they say the application is like at the point where the tension connects to the wall. So I thought maybe I would use point A, but
Well, you could,
I think that
but you want to think. So I guess I can. So what you want to end up, what you want to do is you want to look at this as a free, like this is a free body diagram here. So what we're doing is this is what's of interest. This has the 110. This has the reactions. So the point A is external to it, and so it does connect. The problem with drawing it A pointing the other direction going here is that then there's nothing over here. So you're not, so this is the ground, this is the outside world. So you always want to have your tension. If you have a rope that's connecting or a cable that's connecting your component, you always want to go from the component out. And it's always going to be going away from the component because you can't compress a cable. And the other hint on that
all
is
right.
that if I say tension EA, so EA, the first letter means you're going from E to A. So just those little things, if you can remember those will help you on that. This will, problem like this will come back on the final. So, I mean, it's not a guarantee, but in the past we've had problems like this on the final. So I think that if you look at the study guide, and it's really, it's a very, these types of problems are very recipe. And what I mean by that is the way you approach them. You want to find your point of the most unknowns. That's where you take your moment about, set up all your R cross force vectors. I'm sorry, R cross F moments, and then just set them all equal to 0. And then usually from there, if you get to this point, this is this here, and then getting the matrix set up, that's 90% of the problem or 80% of the problem. And then doing the cross products is most of you can do it in your calculator or not. But I'm not as concerned with these down here as I am with getting this up here.
For me personally, I think the issue, it wasn't the like difficulty of the problem because I understood what it was, but for me personally, I am super slow sometimes when it comes to these problems, especially when it comes to calculating moments. So I wasn't able to get to the very end and give you a full answer, but I was able to at least get to the point where I was like, here's the moment about C. Here's what I calculate. Here's the components. If I had time, this is what I would calculate.
I see. Yeah, I mean, that's good input because, it's always a balancing act as to how much to ask on a test and how much time. And I know that time can be a critical issue. So I would say that in general, from the other instructors that I've worked with at Poly, is that they tend to give long exams, and I think that the more, and I'm not saying that's right or wrong or whatever, but the more you can get down as far as how you did the problem, and the less you worry about getting the exact right answer, the better off you're going to be. And that's how I try to look at it. Hopefully you don't have too many instructors where there's no partial credit, because that can get pretty hairy. But
yeah,
So, I mean, I do look at that when I'm grading them to a degree, and and I may miss things. So that's why it's important if after you look at the test, if you have questions on it, come see me about it. Um, so does that? But otherwise, I mean, do we understand the process? I mean, was there any now? If like say for example, if I gave you this type of problem and you had 3 hours to do it, does everyone feel confident that they could do it in 3 hours?
Yes.
I mean, that's good. I mean, ultimately what I'm trying to do is not give you problems to trick you, but I want to make sure you guys understand the material. So if you go on to dynamics and 204, you feel comfortable with it, that you're not having difficulty recalling stuff from statics. Okay.
I have a quick question.
Yes.
So when I approached this problem, I kind of saw that all of the unknowns kind of lied across an axis, and so I approached it kind of doing a moment around an axis instead, like a BC axis. However, I kind of like looking at my final answer, I kind of went into a rut and didn't get it correctly. Is there like a problem approaching it in that way, or was it possible I just might have done something wrong along the way?
So,
What
well,
do you think?
so
I know
what
it's
you
case
did-
dependent,
right.
in particular, but like in general terms.
I guess it really, you're right. I mean, it depends, but like, for example, you took the moments about the y-axis, which is fine. That gives you tension AE. Once you have that, uh, then the other idea is you could, if you were to take, say, the moment about the z-axis at that point, that would get rid of all your B reactions, but it wouldn't do anything for your C reactions. And so then you end up with more unknowns than you can deal with. If you,
Yeah.
And so that's the challenge in that is it's really how do you eliminate the most unknowns? Because you can only find one unknown by using the y-axis, and that's the only axis that really gets rid of it. So at some point you have to go back and pick a point to eliminate like the C.
Okay, so I guess when approaching these problems, even in 3D, always do a moment about a point.
I
Even though
find that, or
axis
well,
seems like
a
it eliminates,
pointer,
but
yeah, a point or a line. I mean, if you have a line like the last homework problem that has 6 unknowns, then by all means use a line. But if you have a point that has 3 unknowns, that's good to get rid of too. I mean, it depends on what it's asking for. So the fact that you had to find bx and bz, I can't really think of a convenient line. I mean, I guess you could have drawn a line from C to E and then tried to find a moment about that line, but then you still have bx and bz as unknown. So, I'm sure there's other ways to do it uh, as far as finding other lines and other axes. The only challenge with that is when you start drawing weird lines, is you start getting some really funky geometry, and finding your R vectors can become non-trivial.
okay, yeah.
And so you have to think of, the more, I guess, outside the ordinary you go, the more prone you are to having time consuming math to try to figure out. So I try to keep it as simple as possible. It's just my small brain needs to do that, so I just try to, I find a method that works and do it. And I mean, I realize that these are pretty straightforward. I don't know if an advanced statics class exists. We have intermediate dynamics, but I've never really seen an advanced statics class. So, but this, you will actually, if you're an ME, you will use this class later in your design. I know if you have Dr. Mello, he'll have you resurrect statics, so you guys don't forget it, because he'll ask you who you had for statics, and then I'll look like a schmuck. So anyway, any other questions on this problem? You guys good? I will clean these solutions up and post them though, so you can see them. But I always find it more advantageous to actually walk you through them in a lecture than just post them and call it good. All right. So the last problem was the pulley. Now, does this look familiar to anybody? It should look like a homework example. So hopefully you remember this one from the home, or not a homework example, I apologize, a lecture example. It was one of the lecture examples I did. And it was toward the end of chapter 3 when we were doing equivalence. And so it's pretty much exactly the same problem, except with the added 55-pound clockwise moment. And so with this problem, you have to account for those tensions, and you also need to account for the moments that those tensions create. And so they end up creating not only moments about the y-axis by the unequal forces. So for example, if each force was the same magnitude, then there wouldn't be a net moment. But because they're not, there is. But you also have to account for the moments created by the forces pulling in the respective direction. So for example, G, the disk G, the fact that you have two forces in the negative Z direction means they're going to create a moment about the x-axis, right? Because they're wanting to pull and rotate about the x. And that little, excuse me, and the negative x tension on F is going to want to create a moment about the Z-axis. So what you want to see in this final answer is you really want to have a R and F, right? It's an equivalent force couple system at H. So your final answer should be a force and a moment. So if we look at our diagram, we have this, and I got to erase that and put it the other way. So, but 55 foot-pounds, and it's clockwise, not counterclockwise. And then you have the 18, you have this, which is conveniently 26, which means that 5/13 of 26 means you got 10 pounds going up and 24 pounds going in a negative x. And then you have the total of 40 going down. So the first thing you're going to do is figure out what is the total forces. So just like any other problem we've done like this, you're going to sum all the forces. And so the only forces you have are from these belts. So for example, I have negative 18 in the I minus, and also a 12/13 times 26 in the I, and then 0 in the Y, and then plus 5/13 20 and times 26 minus 40. And so what this is my I, and this is my K. So if I add it all together, I end up with 42I, negative 42I plus 0J minus 30K. And so there's 40 going down here in the Z, but there's 10 going up here. So that's why the net is negative 30 in the Z. So most of you got this. So, but unfortunately, this was a small part of the problem because this is pretty easy, just adding these four forces. Then the next part I want you to then determine what is the respective moments created about H by this net force and this net force. So first you're going to have your RG relative to H. So you go from H to G. We know that's just negative 1.5 in the J. And then once we get there, we have just negative 40K. So we have negative J cross negative K. That gives us a positive 60I. So we know we have 60 foot-pounds in the I. That's what's created by this. Then if we go to here, we have F relative to H, and when we get there, we have to cross that with negative 42I plus 10K. So that's the force when we get there. So we know to get there, we have to go to negative 4.5 feet in the Y direction. And then if we do negative 4.5, and we cross that with negative 42I, and maybe have that gives us negative 189 in the K and negative 45 in the I. All right. So, but we had a positive 60I, right, over here. So we're looking for the net moment. So we have 60 minus 45 I. So we end up with 15I minus 189K. So that's the moment created just by the belt tension about from those pulling. Now, the last thing we need to figure out is what is the moment created by the differential belt tension in the around the y-axis. And so that's just in that case, like the problem we did in the lecture, we just add up those. So these are all the moments about the y-axis. So you have negative 55 foot-pounds. Then you have 32 minus 8 times the radius of the disk. And then you have plus 26 minus 18 times the radius of the disk. And that gives me a net of negative 29. Now, if I know I put 52 in the text, I apologize for that. So if you use the 52 and not 55, then you would have gotten negative 26. So either one's correct. So your final answer is negative 42,030 for the reaction force. And the moment is 15, negative 29, negative 189, respective. And just like the example we did. Any questions on this? No, I won't do that kind of quick, but as you digest that, does that make sense? All we're doing is we're just taking account of all the forces and the moments they create. So just think of it, you're a little person standing here, or a big person for that matter, and you're standing here at H and you're looking around. What moments and forces do you feel? And that's what this is for down here.
I have one question.
Uh-huh.
I don't know, it's not a very big thing. Like I said, it's a pretty big thing, but when you're summing the moments about H, are you like, I don't know how to explain it. Like if you're pulling, like, are you looking at H and then deciding if it's counterclockwise or clockwise about H, or are you just deciding that direction about the x-axis?
Oh, so when you're
That makes sense.
Well, the way I found when I'm doing when I'm doing about H is I'm saying that if this is my x-axis is here, right? That's the x-axis with respect to H. Then I'm looking at what moment is created by that, and so that's how I get the sign for it. It's not with respect to this axis. It's basically what the x-axis would be about H. H is x, H is z, H is y.
Okay, cool.
Because everything
Thanks.
is moved there. Sure. Anything else? So I will, like I said, I'll clean these up, post them, get your answers up. So the next section, as I said, is 2D and 3D centroids. So I don't do integration just because I know you guys have done centroids with integration and calculus. It's not necessary given how little time we have to cover all the topics we have. I don't think it's a good use. So I just focus on composites, which is actually fairly simple. Just looking at, square, triangle, circle, finding the centroids of those. I know you guys have done them before, so that's why I don't spend a lot of time on them. I think the lectures I have are pretty self-explanatory. If you have questions, of course, come to office hours. But the 2D and the 3D, that will be potentially for the quiz on Wednesday. So it'll either be a 2D or a 3D centroid. That's it. And then, so centroids I only spend 2 lectures on that, and then I spend 2 lectures on moment of inertia, and that's chapter 9. And that's moment of inertia is something that you'll see right away in C204 when you take it. And mass moment of inertia is close cousins to moment of inertia, and you'll see that in dynamics pretty soon when you start that class. So I would say that overall, this material here shouldn't be as challenging. It's stuff you probably have seen before, and once you see that basic theory, you should be fine. But again, come and ask questions. It's too early to discuss it because you probably haven't even looked. You may not have looked at the lectures yet. But by all means, next week we'll do a quick review on this, and then we'll move on to chapter 6. So chapter 6, which deals with centroids, frames, and machines, we'll spend close to 2 weeks on, and that chapter, there's usually a significant presence on the final. So that's the chapter you really want to understand. And then after that, it's friction, and then we're done. Hard to believe. All right, any questions on anything? Okay, well, that's all I have for today. So I'll be in office hour, and there's a huge rat in my backyard. I just noticed. Son of a bitch. God, that's a big thing. Sorry, I just saw this huge rat crawling. I can't believe it's out here at night in the daytime. I gotta go get it. I don't like killing rats. I like trapping them, sending them somewhere else, I guess. But sorry. Anyway, okay, you guys. If there's no questions, I will see you in office hours. All right. Thank you.
Thank you.
Thank you.
Thanks.
Thank you.
Thank you.